All right, here we go. Okay, let's get my ecology music on. A little bit of songs about food chains and ecology. Gotta love it. All right, what are we doing here today? Oh yeah, it's after school and we got a quiz tomorrow. So, stylus check. All right, make a little drawing. Okay, that's some sort of mushroom. All right, boom. Okay, we got a quiz tomorrow. So this is the review sheet I gave you. I said I was not collecting it. So hopefully that means you didn't throw it out right away. Like, I'm not turning it in. I don't need to do it. No, I do not give you stuff if I don't think it's going to help you. So, yeah, here we go. So I'm glad you're here. Obviously, if you're here, you didn't throw it out. Unless you did throw it out, and now you're like, oh, man, I got to watch the video now. So what I'm going to do is briefly go over this vocab. I generally don't spend a lot of time going over vocab because you can just look up the definition. So I don't want to just be a dictionary. Okay, I'm an explainer. But I'll go over it just a little bit. Okay, energy, it provides function for living things, so you need it. Okay, just know you need it to do things. Example of energy, how about food, right? Okay, that's the basis of this unit, is how do things stay alive by getting their food? Without this, then you die. That's horrible. We saw a lot of things die today, right? Poor little caterpillar got eaten alive. So within a population, I'm going to do population first. I'm not real thrilled with my order, okay? So let me do this, and I'll erase it if I can. Before you start answering questions, just think about what all these words are a bigger picture of. That's why I like concept maps. They tie all these things together, so you're not just memorizing word after word. Okay, we start off with one little individual. What should I draw? Fishy? Sometimes I can draw a fish. That's pretty good, fish. Okay, one individual fish come together. It's gonna be. I can't make the same thing very well. They'll come together and they'll make a population of fishes. So right now I have 3 of the same fish. So that is a population. So it's the same organism together. Okay, so for example, it could be like 10 wolves. Now if I have different fish, all right, that is not part of the population. I have a population of 3 red fish. I don't have a population of 5 fish. I have a population of 3 reds and 2 blues. So I just kind of defined another word right here. Then what is it, Mr. Eibling, when you put 2 different things together? It's not a population, it's a community. So 2 or more living things. So I could have a nice population of killer whales and squirrels. That's not very realistic, but if they live together, they'd be part of the same community. All right, so now we need to build an entire area. So when you think of an ecosystem, think of the entire kind of area you're at, like the Mojave Desert where we're at, or like Lake Michigan, or what else? The Rocky Mountains. That's an ecosystem. It's an area of things that kind of live in the same area and interact. Okay, so living things in the Rocky Mountains interact with each other. We need to add some non-living things. So we're going to add abiotic factors. So I was kind of stressing the word a. And I was really debating whether or not to have you guys learn biotic and abiotic, because, I don't know, it's not really important in your life necessarily, and I could use other words. I could just say living and non-living. But I went with biotic and abiotic, because I want you to know how to learn how words work. So when you put a in front of something, it means without. So without life. So I said, like, if you're a swag, you are without swag. Or if you're a savage, you are without savageness, which, well, that would be horrible. All right, somebody like, I have no savageness. I'm not even going to lie. But so abiotic means without life. They are things that affect organisms in this ecosystem. So things like water, temperature, sunlight. And you'll see other things you don't even think about, like phosphorus levels. Mr. Eibling, what about phosphorus? Yeah, phosphorus. We'll learn about it. For those of you who like plants, you'll know that phosphorus is a big part of fertilizer. Otherwise, I'd have no idea why you'd ever think about phosphorus. But biotic factors are living things. So if I asked you what is a biotic factor that might limit the deer population, Don't tell me water or food necessarily. Well, yeah, food could be. You could say plants. You could say wolves. Wolves are a living thing that would definitely impact a deer population. All right. So then we've got consumer. They eat things. All right. Let me keep it simple. Example of something that eats something. Pick anything that eats something. All right. Any of the millions of animals that eat something. Autotrophs. So auto means they automatically make their food. So they make their own food. So autotroph would be a tough word probably because it's not really something we really use normally. So plants, algae are examples. They make their own food. Things that get it from the sun. Sun to plants is where the energy flows. Omnivore, another kind of tougher word. Omni. How can you remember omni means both? Omni means everything. So if you might have heard the word omnipresent or omniscient. Like some people think like whatever their religion is, their God above is omnipresent. He's always in our thoughts. He's omniscient. He knows everything. Kind of creepy. Someone reading your thoughts, but omnivore means they eat everything, plants and animals. So an example, bears eat fish and berries. Producer. Okay, so what I like these words, they're easy. They produce things. Well, what do they produce, Miss Aibling? Are these animals that make like factories and cars and stuff, arts and crafts? No, they make food. They make food. Where do they get the energy to make their own food? Don't you need energy to make things? So how do you get food? How do you get energy if you don't have food? How do you make the food? The sun. The sun. Boom. All right, primary consumer. Secondary consumer, I'm going to answer a lot of these on the back. So, primary consumer, they eat plants. Okay. Pick anything that eats a plant. All right, bug, grasshopper. Secondary consumer, they eat the thing. They eat primary consumers. So they eat the thing that ate the plant. So what eats a bug? Frog. You got it. My favorite secondary consumer. Third level, they eat the secondary. An example, what eats a frog? How about a snake? They make good third level consumers. Now we got a food chain. Okay, we got the plant getting eaten by the primary consumer. Bug, grasshopper. The frog eats the grasshopper. Snake eats the frog. So let's follow the energy. Energy went to the plant from the sun. Lost a lot of it. Some of it went to the frog after it ate it. And then the energy from the frog went to the snake. All right, so some of the energy from the sun makes the snake. Mutualism. Okay, this is when we have a relationship that is positive. So we saw some examples today. Hopefully it's still fresh in your mind. They work together. So two things that benefit. Pick any example. We saw the leafcutter ant cutting up leaves for the fungus. Fungus grows, the ant eats the fungus, everyone's fed, everyone's happy. The sea anemone. Not too many syllables. You are probably right. I probably need a drink of this Diet Coke here. It's Coke Zero. I'm getting all worked up. Okay, mutualism. So, any of those examples. The goby and the shrimp, if you got to see that one. Not every class did. I'm sorry. We saw a bunch of them. The oxpecker. Okay, the oxpecker ate the ticks off the buffalo and the rhino. Everyone's happy. And parasitism. You should be fresh in your mind, okay? One is hurt, one is helped. We saw some horrible examples. Ticks, leeches, the caterpillar getting devoured by the wasp larva, which is one of the coolest things I've ever seen. Really hoped you liked that, by the way. So I'm always trying to find things that I think you would like. I don't want to show you old, scratchy videos that are, just because they relate to the topic. If you like something, let me know. Be like, Mr. Aibling, I like that video, and then I'll try to find something similar. So I like it when you tell me something that I did that you enjoyed, because that's why I do it, because I want you to like it. So if I do, that makes me feel good, and I'll do more of that kind of stuff again. So anyway, all right, now I'm not a vocab tester, so to speak. So I'm not testing you to see if you know the definitions of these words. What I want is for you to take these definitions and be able to apply them. So do you really know what this definition means, or do you just memorize it? These kind of questions will help me out. This one looks a lot like one from class. So hopefully you don't get tripped up on this. If you get tripped up on this one right here, I'm not gonna lie. If you miss this question on the quiz, I'm gonna be disappointed because we did this and I thought I made it very clear. So that means you weren't paying attention or you have no memory at all, which you do. All right, so the smileys represent a fish living in a pond, and they're happy fish. Okay, so here is a pond, this box, and I got some smiley fish over here, some smiley fish over here. What is true about that? Okay, so what do we have? We have a population. Let's see. So remember, I made this question because I thought if you didn't know really what a population was, you were going to pick 2. So I thought, you know what? If someone wasn't paying attention or didn't study, they're going to think this is one population and this is the second. Look at that. There's 2 populations of smileys. But this is a pond. Okay, remember the definition for population. It's when there are the same species, in this case smiley fish, in an area that can interact with each other and breed. Well, these fish obviously can swim around the lake. These fish can swim over here. That fish can swim over there. And if it's a male and a female, they can breed. And sometimes they can change their gender. We'll talk about that later. So how many populations are there? Mr. Eibling, is it 2? No, this is one population. You will see a question like this. Do not get tripped up. Just because there's 2 groups, they're part of the same population. It's like saying this is foothill and this is basic. Boo! We hate basic. Yeah, well, you might hate basic, but even though they're in separate schools, the kids are all part of the same population of Henderson. So just think of it that way. I like that. That's a good example, Mr. Eibling. Thank you for that. So we have 1. How many communities? So what's a community? So you can't get this question right if you don't know what a community is. Oh, hey, hold on. I got someone at the door. Let me see what's going on. I forgot where I was, so I'm going to go back to communities. All right, so we got 1 population of the same thing. So your gut is going to say, oh, we have 1 community. This is where I'm trying to trick you. Yes, I am. So just because you got these smiley faces at Foothill and these smiley faces at Basic doesn't mean that makes a community then. They're the same thing. So a community is 2 different things. So the answer, totally a trick question, you're going to hate me, is 0. There are 0 communities above. Community means you have 2 or more things interacting. But now you have 1 population of smiling fish. All right? Now let's go to the next one. So you're probably really mad. You put 1. Don't feel bad. Most people probably did. Okay, let's look at my next one. I got a large area with a rocky mountain range. So don't ignore that. That's important. I didn't just pick Rocky Mountain Range because I felt like it. That means something. See that big mountain range? That's a problem. If you want to cross it, you can't. Well, you might, but you can probably get in a car. This is some sort of deer. It's not going to go over a mountain range. That means something. All right, so we got smiling things. In my last one, they were fish. So let's say they're not fish because they're in a prairie. So you can say they're deer, whatever, doesn't really matter. It's not important. But now we got these little Pac-Man-like things. They are a different creature. So we've got 2 areas, okay? So you got to think, do these guys go over here? If they're looking for a mate, if they're looking for a female smiley face, do they cross that mountain range? No. All right, don't think of some crazy example where they burrow a tunnel. No, it's not. Don't think like that, okay? Think common sense. So you got some smileys over on the left with some Pac-Man-like creatures. So you have 2 different organisms together on this side. All right, so you have 1 population of smileys here, 1 population of Pac-Man over here. How many do I have over here? I have 1 population of smileys and 1 population of Pac-Man. So that's a tough one, right? How many total populations? Well, there's 2 on a side. 2 plus 2. Hopefully you can answer that without my help, but I'll give you the equation. 2 plus 2 equals 4. Yeah. That's about the hardest math you're going to have to do on this. So I should probably go back to those percentage questions that you love so much. You know what? I am. So be ready for percentage question. Maybe I'll do a review. How many total communities are shown by the picture above? Communities. So what's a community again? Good answer. Yes, 2 or more things working together. 1 community, 2 communities. All right, we just got some nice clean desks. Thank you, Interact. So thank your Interact for your clean desk tomorrow, or today, depending on when you watch it. All right. How many total communities? Sorry, you probably thought I'm crazy. There are 2 communities. All right, hopefully that went over it. Hopefully I didn't confuse you more, because that's what I want to do. I want to confuse you. Like, you probably got these wrong. I mean, if you get these wrong, that's okay, because the answer wasn't the obvious choice. I want to confuse you and then unconfuse you. So I know you probably thought there's 2 populations here maybe, but there's 4 populations. 1, 2, 3, and 4. So that's a little tricky. So be ready for that tomorrow. So if you watch this, you're going to be ready. All right? The other students who didn't watch it, man, they're going to get it wrong. But they might surprise me. Okay? Sometimes they're smarter than I give them credit for. All right. I'm going to take a drink of Diet Coke, Coke Zero, and then I'm going to go to the next slide. Okay? So we're going to have nice clean floors tomorrow, students. So please respect that. Okay? I've got Interact. I've got some wonderful Interact students cleaning my floor for me, so try not to get, your garbage on there tomorrow, right? Let's keep it clean. All right, so say thank you to the Interact for our nice clean tables and floors. But anyway, you didn't come here for that. You came here to put trophic levels in order. All right, so what I got here is a pyramid. So let's read the directions. Read the directions, all right? Don't just look at the word and say you don't know what it is. Place the following in their proper energy level. So we did this as our bell ringer today. So this is the bottom of the food chain. Always have something green here, like a plant. So let's see. Let's find our plant out of this group. What is our food-producing organism? Oh, it would be the primary consumer. So I'm going to write primary consumer in. Okay. Oh, you're Mr. Eibling. You just goofed that up. I'm going to erase that. Ignore me. Okay, so hopefully you saw that I was wrong. Primary producer. See how easy that is to mix up? So producer. Always have some sort of producer at the bottom. If you look at your pyramid and there's like a lion on the bottom, you are going to be wrong. Fix it. Make sure there's some sort of plant down here. If the lion is the start of your food chain, think about that. That's a problem. All right, so what is going to be above the producer? What is going to eat the producer? Now we got our primary producer. So remember PP? PP, right? Producer, plant. Producer, plant. So be thinking PP. And then we got TT coming up. So we got primary consumer. So let's pick a plant. What do you want? You want a fern. Oh, that's lovely. Okay, so what's going to eat the fern? I'm so sick of using deer, but that just always comes to mind. So we're going to put a deer here. You know what? Let's use the zebra. Zebra. Zebra eats the fern. Primary consumer. So now, unfortunately, we got to have something eat the zebra. What's going to eat a zebra? Well, a lot of things. Thank you. Secondary consumers. So secondary. All right. So remember, whatever's on top eats below it. It's kind of like the boss. The boss gets to yell at the person below it. So, like, where would I be? Where would Mr. Eibling be on this? Let's see. I'd probably be, like, right here. So, like, the principal is, like, right here. So he yells at me. I can't yell at him. He can yell at this guy, who's probably the administrator. I think it's Mr. Love. All right, you know Mr. Love. So Mr. Caruso, principal, could tell Mr. Love what to do, and then Mr. Love could tell me what to do. Mr. Eibling, you could tell the principal what to do. Yeah, but it wouldn't be good, all right? So remember, it always goes down just like that. So this can't eat above its food chain. And then what goes above that? Tertiary. How do you remember that, folks? TT. Remember, I don't care if you ever use the word tertiary in your life. What I want you to do is practice making memory connections. Tertiary to third, TT. So I was tempted to just put third level consumer. But I want you to practice your brain how to memorize things. Okay, so now, Mr. Eibling, now you scratched it all up. Now you got to put all these in order, and you already put like zebras in there and stuff. So remember, producer plants eaten by primary consumers, eaten by secondary consumers, and then whatever eats the secondary consumer is your tertiary. Mr. Eibling, what if something eats the tertiary consumer? Oh, that was a quaternary. Remember the quad 4? That's the 4th level. And we'll see some of those. A lot of times they're like hawks and owls and stuff. Birds of prey are usually 4th level consumers. So, all right, put the following organisms in their proper energy level. So each one of these is an energy level. So I get to that here, what the energy means in a second. Put the following organisms in their proper energy level above as they would appear in a food chain. Okay, grasshopper, snake, frog, hawk, grass. First thing you do is don't try to do everything at once. Start at the bottom with grass. Grass goes right here, okay? So now, what eats the grass? Primary consumer. So what's most likely to eat the grass? I'm assuming you know what these are. I'm not testing your knowledge on grasshoppers, but I'm hoping you don't put like snake eats the grass. I'm hoping you put grasshopper. Okay, so now, what eats the grasshopper? Oh, I'm thinking frog, right? Frog. Oh, look at this. I didn't even realize this happened. Now, snake. Uh-oh, I goofed. Something happened. Uh-oh, Mr. Eibling's confusing you. I should go back and delete my video and then go back in time, but I'm not, because I want you to realize when I'm wrong. Because when you know I'm wrong, that means you know it, and I love that. When students are like, Mr. Eibling, I think you're wrong. Call me out. Don't let me get away with that junk. I mess up all the time. I really do. Our frog is our secondary, so here's our frog. Mr. Eibling, all this blue and red is craziness. I know I'm trying to erase it, but it's not letting me. But follow along. Okay? That's why I'm doing this. So we got grass, grasshopper, frog, and what eats the frog? Actually, there's two answers here, but if you have to do both, the hawk is more likely to eat the snake. So I wouldn't mark you wrong on this, but I would go snake, and then you might be like, man, I need another level up here for that hawk. So the hawk actually ended up being a quaternary consumer, so hopefully you weren't pulling your hair out trying to figure out what to do. Remember, just because it's like, Mr. Eibling, there's 4 boxes and 5 words. All right, don't freak out. Okay, just think, how am I going to fix this problem? Make another box. Okay, assume you're right and assume this is what's wrong. Okay, be confident. All right, don't be like, oh no, I'm panicking. No, I just kind of didn't give you enough boxes for your awesomeness. So, yeah. So I'm not encouraging you to start yelling at me in class, but if you think I'm wrong, all right, call me out. And then if you find something wrong, I appreciate that, because I don't want to teach it wrong. I'll hook you up. I'll give you some jawbreakers or something, or whatever. Some fancy, I don't know. I don't want to get myself in trouble. The bottom of the pyramid is the largest. What do I mean by the bottom of the pyramid? This right here. So why is it bigger than the other ones? What does it contain the most of in a food chain? 2 possible answers you might be thinking. One is it has the most creatures, which is kind of true, all right? You're going to have a lot of different plants here. But this reflects energy. Okay, there's a lot of energy. Think of all the plants. We saw those videos today of like the different bugs eating all the plants. They would never have trouble getting energy. Okay, insects in a forest are going to have tons of opportunity to get energy because they can eat plants anywhere. I mean, they were going crazy on those leaves. But as you go up, energy becomes more scarce. So just think about it. If you're a hawk, all right, that says, oh my gosh, that says hawk. I need to totally look at this pyramid. It's out of control, but hopefully you can figure out what's going on. I apologize. Hopefully I'm clear. If you're a hawk, you're up here, okay? So let me see if I can erase. That's anything but an eraser. I don't know why. I got to figure out why it lets me erase some things, but I don't want to distract you. If you're a hawk up in this level, okay, think about how much harder it is for a hawk. How does a hawk get energy? It flies around for a long time till it finds a snake it can eat. There's not a lot of snakes. That means there's not a lot of energy. So while it's good to be at the top because nothing can eat you, it also means it's going to be hard to find energy. Like these bugs here, yeah, they're going to have things that are going to eat it, but they will not have problem finding food. Okay, so energy is lost. And remember that. Energy is lost as heat. You burn it. When you burn energy, nothing else can eat it. It's a problem. Okay, so what does it contain the most of? Like Mr. Eibling, just write in the answer. My gosh, all that, and you just had to put energy. But I don't care. Like, I'm not going to just ask you this question, just remember energy and write it in. Okay, I want you to know why it's energy. Okay? All right, because anyone could write in energy there if they memorize it, but they might not have any idea why it's energy. That's what I want you to know. I want you to have actual learning having occurred. Amazing, right? All right, almost there. Draw a line between the words on the left and the word on the right that is most similar. Okay, so you want to look at all of them. So, all right, I got a fresh, clean start here. Take it all in. Okay, before you start drawing lines, try to think of how everyone's going to match up. So do like a little practice. So, herbivore. So you should think, what is like an herbivore? What is an herbivore? Okay, it's a plant eater. It's a plant eater. Okay, an autotroph, what does it do? It makes food. All right. A lion, what does it do? It eats animals. All right. What's an omnivore? It eats plants and animals. All right. So now that you got that down, let's match them up. What is a plant eater? Producer. What do you think? Is it producer? Billy. How you doing, Billy? Billy says producer is an herbivore. He's wrong. No, producers are plants. Herbivores eat the producer, but it's not most like an herbivore. So I'm thinking herbivore is going to be like primary consumer. Because what's an herbivore? A plant eater. If you look back at the pyramid, all right, up there, can you go up there? See me scribbling that in? That's where the primary consumers are. All right. Autotroph. What's an autotroph? Makes its own food. Which one of these makes its own food? Hopefully you don't say carnivore. Okay, because carnivores eat meat, and they don't, like, make the meat. That'd be weird. They cook it, Mr. Abeling. You can cook it. Yeah, but you're not making it. You're just making it taste better. And easier to digest. We'll talk about why one of the main things that fire did for humans. Fascinating. Second semester, little tease. Producer. All right, let me make that blue again. Lion. Lion eats meat. Carnivore eats meat. All right, hold on. Oh, I got my different colors here. Sorry, little break there in the action. Whoa! All right, you want me? What's that? Rainbow color? What is? Oh my gosh! You know what? Give me a cool color. Give me this thing. I've never used this color in my life. Let's see. Oh, that's pretty. Pink. Lion is a carnivore. Omnivore eats both. This one's probably the hardest. So, let me do a little. You guys know what a Venn diagram is? Okay, you don't. All right, so let's do a Venn diagram. So we've got omnivore. Okay, omnivores. Actually, this is a bad idea. I think I'm going to make this really bad. I don't know how I'm going to explain this with a Venn diagram. And you know what? I think I can do it. Secondary. Okay, so that means all second. Okay, I got it. I've recovered. So here we go. Here's. Oh my gosh, I need a different color. This is a bad idea, Mr. Eibling. You should go back and delete it. Nope, I'm rolling with it. So what did I just do? I made, there we go. See this big pink circle? All right. So hopefully I'm not losing you. So think critically. So if you've been just kind of spacing out, listening, now you need to apply your brain a little bit because now you're going to have to understand what I'm doing here. So this whole pink circle is secondary consumers. Okay. This pink circle represents secondary consumers. What is this blue circle that I drew in here, and why did I do it? This is omnivores. So why is it just a small chunk of secondary consumers? Because every omnivore is a secondary consumer. So every omnivore is going to be in the bubble of secondary consumer. Because if you're an omnivore, you eat meat. So you have to eat some sort of plant eater. But Mr. Eibling is, I'm going to make a quiz question. So if you're watching this, you're going to be happy. Okay, so is every secondary consumer an omnivore? Let's look at it. So let's think of some secondary consumers. All right, are there secondary consumers that don't eat plants? Let's say we have a plant, and then we have a deer eating the plant, and then we have a lion. Okay? All right, this is easy. Do lions eat plants? Hopefully you say no. Can they be an omnivore if they don't eat plants? How's it going, Zach? I'm not going crazy over here. I'm making a video. So this is on YouTube. So you can watch on YouTube.
Oh, you put it on YouTube?
Yeah, so I'm talking to my students right now. So you want to say hi to them?
What's up?
That's Zach. Say hi to Zach if you ever see him. Good guy. Okay, so is every secondary consumer an omnivore? The answer is no. We just proved it. Lions don't eat plants. So every omnivore has to be a secondary consumer. But not every secondary consumer is an omnivore. So if I just blew your mind, just slow down a little bit and think about it. Because I promise you, I'm going to make a test question or a quiz question about it. Oh, by the way, watch these videos because a lot of times I think of good questions while I'm doing it. I just did. So there you go. Don't tell anybody, or you watch the video. Don't give it away. All right, so omnivore is most like a secondary consumer. Does an omnivore have to be a secondary consumer? Yes. Does a secondary consumer have to be an omnivore? No. Okay. All right. If that's confusing, see me tomorrow. I will be ready to rock in my room at about 20 to 7. So if you want to go over it with me, I'll be here. All right. Maybe I'll bring some donuts or something, which is, I think, totally legal according to this school. Hey, don't hate me. All right, I didn't make the rule. All right. Whew, this is a long one. That's good, though, because longer the better. That means more explaining. All right, so now this is where a lot of us struggle, but we're going to get better. Okay, so other students in other classes, other bio classes, when they get this kind of question on their ACT, I think they're going to get dominated. But you guys are going to have an advantage, I think, because you guys are practicing. You're not scared to go at it. Okay, so we're going to tie in graph reading skills with our ecology. All right, so I'll try to find a way to get this on the quiz. I like to modify it the day before. Does the graph show a biotic or abiotic factor affecting populations? So what am I testing here? You need to know the difference between abiotic and biotic. So living, non-living. Okay? And you need to understand cause and effect. So I brainwashed you. What goes on the side, cause or effect? Effect. Okay, and this is the cause. So what does that mean? That means, according to this graph, whatever they studied, I made it, by the way. I totally made this graph up, which I do sometimes if I don't like what I find, is that the inches of rainfall in a population area affects the, oh boy, you can't even see that. That's a problem. Hopefully on your sheet, I forgot to look, it's population number. So hopefully you figured that out, because it says effect of monthly rainfall on populations. So hopefully you were kind of keen enough to think this is population number. So don't be like, oh my gosh, I can't see it. I can't do the problem. Don't be that person, okay? Be the person who, like, you know what? It's not there, but I'm smart enough to figure out what it's supposed to be there. Those are called problem solvers. Those are people who take problems and make a solution to make our world better. Be that. There's my speech. Okay, so is this basically is rainfall? You're like, just answer the question, Mr. Heibling. I know, but I get excited. I love doing this. That's what I like doing in class, but you don't have time. Inches of rainfall. Is rainfall biotic or abiotic? A. Like your grade after you're done watching this. It's abiotic. Rainfall is a non-living thing that affects the population of 3 plants. Whew, now here's where it gets tough. So hopefully you didn't give up, because you can answer this. And like I said, I've never asked you a question like this. Mr. Abbey, you never taught it to us. I set you up to learn it. So you have to do it on your own here. A bad drought. Okay, so what's a drought? Dry spell. Has just hit, and this is an error. It's supposed to be 3. Probably didn't even notice maybe. Which plant's population will be less affected? Mr. Eibling, that has to have an apostrophe because that's a plural. That's a possessive. I'm sorry. Which will be the least amount affected? So after the drought hits, okay, these populations of plants, which one will be the least affected? So what is this graph showing us? It's showing us the number of rain. So just think about it. Okay, which plant does the best with not a lot of water? Which plant does the worst when it's dry? So let's look at this one right here. It should be plant B. Okay, so plant B, this line, okay, with only 5 inches of rainfall, has a pretty good population. Okay, the other ones don't do very well with a lot amount of rain. So as you see, the rain goes up. Okay, as the rain goes up, okay, the population of each goes up until it's too much, and they like drown. But this plant B is very stable. Okay, it has a very happy population here, so it can handle change. It doesn't matter if it's wet, dry, really. It's going to have a nice population. So which one would be the best equipped? Which one would die off the least in a drought? Hopefully you picked B. All right. Hopefully you picked B. So I'm going to use this same graph tomorrow and change the questions. All right. 2 of these plants compete for an important resource. Which 2 plants appear to compete? So competing is like there's only so much something to go around. So 2 plants might compete. Now they don't get up and fight, but there might be a resource. Sometimes it's sunlight. Okay, sometimes you might see plants, they try to get higher than each other. So this is more true with animals, but we're going to make it work with plants. So which ones compete? So what happens when things compete? Well, if one wins, if one wins a competition, then what happens to the other one? It loses the competition. So this plant right here, plant A, goes up a lot. So as it rains, as it provides enough rain to boost population, plant A goes way up. Well, what happens to the other plants as plant A goes way up? Well, there's not enough room probably for every plant. So which one goes down? Which one suffers because plant A is going up? Not plant B. Plant B is just steady. Plant B is just chill. You know, it could be hot, wet, dry, cold. It don't matter. It's just going to be chill, right? It's even keel. Whereas population of plant C goes down right at about the same point that population A goes way up. So let's say it's space. There's not enough room for all of plant A and plant B. So plant C is not, or plant B is not affected. Okay, it is totally. It might not even be like a root-growing plant. Okay, it might grow on the side of some sort of tree or a mountain or something. But anyway, so which two is it, Mr. Adeling? Just give me the answer. You're talking way too much, like 40 minutes of this video. It is gonna be plants. You already know the answer. Hopefully, don't wait. Okay, don't wait for me to tell you the answer. I just gave it to you. Okay, so you should be putting it together. Don't wait for an answer. Do it yourself. All right, I'm going to give it to you. Don't worry. You're like, no, you don't leave me hanging. It is plant A competes with plant C. All right. Mr. Abeling, what is your goal as a science teacher for us? My goal is for you not to know the difference between an abiotic and biotic factor. It's not that important. But applying that knowledge to be able to do this is awesome. So if you are able to do this, okay, by the end of the year and do it from a lot of questions, then we both won. Okay, you are doing exactly what I think is going to be very important in your life. Okay, solving problems that you have no idea going into. All right, so I'm not going to ask you to regurgitate 4,000 things to me. You're going to see stuff you've never seen. I'm going to ask you, hey, you fix it. So good job. Man, that was a long one, but good. So what's going to happen now? Well, obviously I'm going to post this to YouTube, but if you're watching it on YouTube, that means I already posted it. So that always drives me a little like weird, like time travel. So here's the deal. I'm going to give you a code word. The code word is symbiosis. What is that, Mr. Abeling? We had in class today, symbiosis. So if you see me tomorrow, say the word symbiosis, okay? That lets me know you watched this whole crazy video, and you're going to get some tickets. Don't tell your friends the word. Why? You watched it. You watched this whole thing. Okay, you earned it. They didn't. Plus, if I have like 100, let's say I have like 10 views on YouTube, and I got 20 students telling me the word, I know something's up. We had a watch party, Mr. Abeling. We had popcorn and drinks, and we all watched it on the big screen. Lies, okay? You're not going to fool me. All right, so if some of this didn't make sense to you, which probably is still true, come in the morning. I'll be ready to go, okay? Like 6:30, 6:40. As soon as you walk in, I will drop what I'm doing, and I will go over this stuff with you. So, all right, have a good night. Tomorrow will be Friday, TGIF. Today is sure happy it's Thursday. All right, I'm out. Wait, it didn't do the pot? No, it didn't.